Good morning, and thank you for coming to attend this talk. I was joking with John that I was supposed to give you a talk with Owen Woods, and at the last minute, Owen kind of bailed out on me, so here we are. The reason why I thought about giving this talk was because, I live in what's known as innovation world right now. And please don't ask me to define innovation because it's such a difficult word, concept to define. It's, innovation could be anything you do, which you're doing today that you didn't do yesterday. It's probably a definition. But the one thing common with innovation groups, at least in financial services, at least in the US, is that they have no time for software architecture. It's absolutely amazing to watch. It's almost an extreme case of agile. And they basically, software architecture, who cares? And they get themselves into pickles again and again and again. And typically what happens is they build MVPs, minimum viable products. You all heard of MVPs, right? So now we have an MVP, and what do we do with it? Well, we have to scale it. Oops, that's not so easy. You don't have architecture, so what do? You rebuild the whole thing. Also, they tend to be one-offs, okay? Great idea, okay, this kind of works, and then we do something else. Done. And if someone wants to reuse the idea, well, guess what? Start again from scratch. Happens again and again. We're going to talk a little bit of AI and ML this morning, artificial intelligence, machine learning, and this is all about data. If you remember one thing about this talk, it's all about AI, ML, it's all about data, data, data. And the problem is not just the raw data. It's curated data. It's labeled data. It takes a long time to label data. And yet, people don't architect that data. It's absolutely crazy, so they can't use it, reuse it. Chatbots. Chatbots are one of our favorite animals. They proliferate, they're like bunnies. Probably, you put one chatbot in a company, and before you know it, you have more than one. But they don't talk to each other. That's a problem, okay? And then blockchain. I mean, I trust that most of you attended the Len Bass excellent presentation yesterday on blockchain. And you're going to have another one on blockchain this morning. Blockchain will impact your architecture, whether we like it or not. Unfortunately, when people do blockchain projects, they don't really think architecture. So what we'll talk about today is really three quick use cases, okay? Some working with AI, working with virtual assistants, and working with blockchain. So the first thing I like to do is kind of baseline all of us on what is AI and ML, because that's probably the hype thing. And the picture on the right, sorry, your left, the picture on the left is the classical picture. AI is meant to be a superset of machine learning, which is supposed to be a superset of deep learning. And personally, I don't like that, because the problem is we don't know what AI is, besides incorporating human intelligence to machines, whatever that means, okay? So if you humor me for this morning, we're just going to use AI as a synonym to deep learning. Because that's really, to me, it's really the best way to define AI today. Now, a year from now, things happen very quickly in this field. A year from now, there could be a different definition, but today, it's the easiest thing to do. Machine learning, okay, well, we're human beings, right? So you basically, how do you recognize a fruit? A banana, a grape, an apple. Is it round? Which color is it? And you get, that's how your brain functions, okay? So it's very easy to just turn that into code. Okay, in this case, you have basically one for basically a round shape, 0 for yellow color, and you train a little model. Fairly easy. Okay. The only trick of that is, of course, this is not a rules-based. This is non-deterministic. So the model trains itself. Unfortunately, what happens if you get more data? So now you have basically something that is not part of the model fails, okay? So that's a problem in machine learning. So the way we solve it, we get more features. So now you have a data set that starts increasing vertically and horizontally, okay? And that's really the big challenge of machine learning is basically you need to get more data, more feature all the time. We have this concept of training sets. You train your model using a training set, and you test your model using a testing set, and the two are different. They cannot be the same, because if you test with a training set, then you test nothing, okay? So architecting your data becomes absolutely critical. If you don't architect your data, you got a big problem. Okay. So now we move to deep learning. Deep learning, it's a very controversial field. Deep learning, the term was actually coined, I think, around 2010 by Ang, and he was working at Google at the time. And it's really it's the same concept of machine learning. That's my definition, at least. Same concept of machine learning. You have this concept of algorithm, which basically allows you to process data and learn from data, except it's implemented. The key thing is implemented through a neural net, which is this construct of several layers. Instead of just an input, an output, and a processing in between, you now have layers that basically can process a lot more data a lot faster. And that's absolutely critical for deep learning. So types of deep learning, they're all neural nets, the fully connected neural net, autoencoders, and so on and so forth. And machine learning is much more than deep learning. The thing is now it's more and more focusing on deep learning. So for those of us who lack code, and this is, of course, Python, this is an example of a neural net. And you see the 3 layers. This actually is a simple example. You only have 3 layers. The embedding layer that turns, this is a text classifier. Embedding layer turns basically the words into vectors. Okay? The convolutional layer basically starts filtering those vectors, and the dense layer starts applying operations to those vectors. Don't ask me more about that because I am not a data scientist. That's as far as my knowledge of I have data scientists that work for me mercifully. But this actually, it's not a lot of code. Okay. Now, what's the problem with this is basically, and a lot of people basically will deal with models like this, just deal with the code, just calling the different models, and don't really understand the statistics below the model. And that's a problem as well, because the statistics can get very involved. Now, what do we do with all that stuff? Okay. Where I work, at least in insurance, there are 2 big applications of AI and ML. And the 2 applications gravitate around images and text and natural language. And they're both high dimensional, a lot of dimensions. Okay? So why image is important? Well, because basically you want to find out very quickly. For example, you all heard of the wildfires in California. And California has now a rule, actually it's a law, that says you should not have any trees within 3 meters of your house. Okay? And there's a reason for that, is if you happen to have a tree within 3 meters of your house, your chances of basically losing your house in a wildfire go down to 0, from 20% to 0%. So, of course, you have 2 ways to enforce that. One way is you can send a lot of adjusters to a lot of houses, and California is a large state. And by the way, it's more than California. And that's going to take you years and years. Or what we do, we actually use aerial photography. We are part of a consortium called NICB, National Insurance Crime Bureau. We have planes that fly basically especially above cat areas and take very high resolution images. And we're able with that to basically automatically detect which houses are too close to trees or which trees are too close to houses. And that is, we got finally the models to work back in February this year. And for us, it's a big savings. It's a big thing because we're actually thinking about making those models available to the industry in general. Because that's huge. Anomaly detection in images as well. That's important as well, for ability to detect solar panels on roofs and so on and so forth. We all heard that AI is going to replace all of us. That's not going to happen. I don't think it's going to happen. What's really going to happen is that AI, more and more, is going to be used to augment what we're doing. And you're going to see that happening. So this is kind of a simple example. AI assistant to a CSR. And just think of what AI can do, monitor conversation, give suggestions, and learn from a response. This learning thing, which is so important in deep learning. Okay. Another example, since this is, after all, an architecture talk, let's talk about architecture a little bit. Another example is AI-assisted search. What happens, this was actually a real case. We have underwriters. And underwriters are basically, think of them as salespeople. That's when you think of underwriters. And underwriters basically do a lot of searches on documents. And what you see here is a traditional search, okay, Solar, something like this. The search will return a bunch of suspects, a bunch of documents, but now you have, as a human being, you have to go in and read each document and find out, okay, so I know that this keyword is somewhere in this document, okay, but now I want an exact match on the intent, not just on the words, but the intent. And we do that with basically AI. So the whole concept of NLP and NLU comes to play in this. This came, by the way, from a Google project, which is, I don't know how many of you have used Talk2Books. So Talk2Books was a Google project back in, they came out with a paper in May of last year. And this was the first time you actually had an AI-assisted search. And we're able to take this and within a month basically implement it and basically use it for that search, which is very nice. Okay. Now, a little bit of what AI is not. Okay? AI is not magic. Okay, don't expect AI to basically handle all your emails, organizer calendars, can't do that. Okay, and so on and so forth. What AI does is solve a specific problem. For example, we have an issue in one of our groups, okay, which they get a lot of emails, okay, and those emails are sent by agents, okay, and those emails could say, okay, I want a new driver. I want to change the location where I keep my car. I want an address change, and so on and so forth. We use AI to actually classify, and this is all free form. We use AI to classify those emails. AI can do that perfectly. Okay, but remember, AI doesn't do, there's no magic, or at least today. Maybe tomorrow will be magic, but not today. Okay. So now what have we learned as part of this 2.5 years or 3 years that we have been basically working with AI? Okay. Again, data architecture matters a lot. It's all about data, and you need to organize your data. Okay, labeling data, it's a royal pain in the neck. Okay, it's not easy. Some data can be labeled using things like Amazon Turks, for example. That works. Some data cannot, because if you have, for example, any legal data, we do a lot of work with legal documents and so on. You can't. Basically, it won't let you do that. So you've got to find ways to actually label data. It's a pain in the neck, royal pain in the neck, manual thing. Okay. Eventually, unsupervised learning is the goal. We're not there yet. I mean, if somebody can do it, please talk to me. I love that. Okay. One thing that people don't talk too much about, AI models decay over time. Okay. As they get more data, they start developing bias, and that's a problem. That's a very, very big problem, because now if you have models, let's see, there's a case, which one, was it at Google? Or I forgot which one was it, where actually I had a model that was used to screen applicants. And the darn model started developing a bias. And you can imagine the consequences, and they had to pull it out quickly, because you can imagine the consequences of having a model that screened applicants that developed bias. So what's important is basically each model has a life cycle and needs to be monitored and will be refreshed. Right now, on our models, we use once a year, but it actually, so depending on the model, it could be more frequent. And you need to retrain the thing. Okay. Hybrid architectures are the future, definitely. I do believe that. So I think more and more, in any software architecture, you're going to have some AI part of that architecture. I mean, if you're not, in your company, if you're not exploring AI today, please start. Okay, it's really, really critical. Augmenting people is the goal, of course, not replacing. We're not about replacing. And eventually, I think AI assistance is going to impact what we're doing. I think today, we're actually working with an Israeli company. They have developed a very interesting piece of AI that actually starts as you start writing code, and the thing works on Java right now. But if you start writing code, the AI starts suggesting what you want to write next. I think the day where we're going to have AI doing architecture is not that far. Assisting us, not replacing us. Okay? So it's important also, do not just throw AI over the wall and just try to implement it. It needs to be architected. It's very, very, very critical. Okay, so chatbots, kind of. Now, application of AI, chatbots, okay? What is a chatbot at the end of the day? A chatbot is, first at the beginning, you can come up with a simple chatbot. You have someone that talks to a script, okay? Problem with that, it doesn't do much. So what you very quickly start doing, say, okay, so because talking to a script, that means you have to say exactly what the script can understand, and that's hard, okay? So now we want to really understand what you mean by type what you type, okay? Perhaps you didn't exactly type what you wanted. The chatbot has to guess what you actually meant. So the whole concept of NLU, natural language understanding, is absolutely critical. Okay, so now things get a little bit more complicated very quickly. And what if we start needing multiple instances of chatbot? Well, we know to solve that in architecture. Okay, we start putting a load balancer in front of them. If you want to scale, you need a load balancer. It starts sounding a little bit like a typical software architecture problem. And of course, very quickly, people who implement chatbots want to implement a large chatbot because this works for one domain. Let's extend a little bit the domain. Let's extend the domain. Okay, ask me anything, right? All intents on multiple domains, all interaction with user, and now you have hundreds of lines over 100 stories on dialogue management and 1,000 expressions. This starts sounding to me like a big ball of mud, which is exactly what that is. Because what happens next is this. Hard to maintain, okay? Multiple teams on the same training data set, basically a mess. Release schedules tied to everyone being satisfied with changes. So you got to have everybody was ready to release. That means you never release. And multiple teams in one single code base, which is basically a problem as well, because you need to synchronize. So what happens? We start sounding a lot like microservices now. Okay, so now we have a lot of chatbots. So we start one chatbot, we have the big chatbot. Now we are back to one small chatbot. Okay. And so you can have a chatbot for tech support, one for product catalog, one for incident management, and so on and so forth. You start having a federated architecture. Okay. The problem that you have now, fine, you solve your release problem, but now how do you talk to all these chatbots? How do you know which chatbot to talk to? Well, now, you really got a gateway issue because your user doesn't want to talk to multiple chatbots. I mean, that's really craziness. Okay, I want to talk to basically one thing. Okay, and so should we send a request to every chatbot and let the chatbot decide, oh, it's not me, next, and that's in theory workable. The problem with that, it will take a long time to get an answer, and those chatbots are synchronous. They are synchronous. Okay, people usually use those chatbots want an answer fast, and that is not going to give them an answer fast. So enters what we call a route dispatcher. So full disclosure here, we use a framework called Rasa, which we kind of like, but Rasa is an open source framework developed by a company in Germany, which is very nice framework. And the answer to the problem is, well, that's our name, the route dispatcher. Okay. The route dispatcher is something that basically starts working a gateway. And it's basically, it resolves the dialogues. It gets what the user wants and they say, haha, I need to pass this to this chatbot. It's a chatbot itself. Okay? So this works very well, or this eventually works very well. Okay? So playing with this, what have we learned? Well, the multi-domain chatbots, which is something logical, there is no escape to the multi-domain chatbot. It's hard. If you want to scale your chatbot, if you want to do more than one strict domain, it's hard. Okay, Docker and Docker Compose is your friend. Okay, all these chatbots live in a Docker container. Okay, being to use Compose is of course a big plus. Okay, you're going to start having some unusual. We had those unusual behaviors with chatbots that start talking to themselves. Problem with chatbots talking to themselves, it's kind of disturbing. There are no analysts for chatbots, too bad. So they start consuming a lot of resources. Okay, that will happen. Okay, you start getting model mismatches. Okay, you thought you trained your chatbot with the right model. Unfortunately, you didn't. Okay, you didn't use the right data set, and now the results are interesting, to say the least. Okay, balancing data going to have, because those chatbots are going to access data. This is all microservices all over again. It's absolutely basic. Balancing data is more an art than science. Okay, and what you're going to find out is because you have this system of chatbots, new features. Some person is going to come and see you and say, "Hey, I just want that small change," and that small change is going to destroy your whole ecosystem of chatbots. Kind of interesting. So some takeaways from an architecture viewpoint now. Okay, it's all about modular architecture. Okay, basically, you really want the chatbots to do one thing and only one thing. The moment you start having a chatbots that start doing multiple things, it's like microservices. It's bad signal. Don't do that. Okay, it's federated. Anyone can play. Of course, the more chatbots, the more fun. But be careful. This was not our first swing at the ball. This was actually our third generation chatbot before we actually got to get that to work. Not easy. Okay. Very much a work in progress. We're still researching, and we actually at this point we're rolling out a new architecture every 6-7 months, which is kind of interesting. We also, what we do, we tend to use our own employees as guinea pigs. Okay, so that's another lesson learned, which is not on this slide. If you only don't do that. Your first swing at the ball. Don't do that with customers. Try not to do that. Okay, do that to employees. Don't do that to customers. And of course, basically, if you want to avoid chatbot anarchy, you have to have an architecture-led approach. That's very, very critical. Okay? So that's for chatbots. Now comes the third one, which is blockchain. Now, blockchain, I know that we're all talking a lot of blockchain. Actually, I think there's a correlation between adoption of technology and the talk that Len Bass is giving. Because 2 years ago, he was giving a talk on Docker, and Docker took off. So I'm hoping since he gave a talk on blockchain is going to take off. Yeah. We can hope. Okay, so blockchain, you all heard about blockchain, basically. So this is a Wikipedia definition. It's a list of blocks, and it's all about cryptography, of course. Cryptography is very, very important. Okay, and basically, it's immutable. Basically, once in a chain, you can't change it. That's one of the hardest concepts. It's there forever, which is kind of something I always had a problem getting my head around that one. Verified, definitely, is to be trusted. Okay, permission, not everybody can access everything, of course not. Okay, the smart contract is really the future of blockchain. This is really where blockchain starts interfacing with AI. Okay, the whole power of blockchain is really to enable those smart contracts. And of course, the shared ledger concept. So, kind of blockchain 101, right? Nothing surprising. Now, what's a little bit more interesting is that recently there has been some fairly new development. And basically what you have on the left is your traditional blockchain, Ethereum, Bitcoin. What we see on the right is distributed ledgers. They are emerging. And of course, the one that we happen to work with, because we happen to work with a consortium called RISBlock. And RISBlock has adopted R3 Corda. R3 used to be themselves a consortium. They reinvented themselves as an insurance company, a software company in Zurich, Switzerland. And they really created something which is kind of a blockchain, but not quite a blockchain. So I still call it a blockchain, but it's a little bit different. So it's important to understand the difference between the two. Okay, on the left, it's really very flat. Okay, it's basically all data across all nodes. Okay, it's public and private, but the intent is public. Think Bitcoin, right? Decentralized autonomy. Okay, basically the network structure is a large, basically flat network. Everybody can play. On the trust is distributed, so everybody, you have this concept of miners, right? Everybody can basically enforce trust. Okay, the consensus is proof of work, what the miners enforce. Of course, cryptocurrency is the app. That's the killer app. And this is susceptible to the 51% attack. 51% attack just means, for those of you who don't know, that it's theoretically possible. I don't know if it's ever going to happen, but it's theoretically possible. Miners can take control of 51% of the resources, and at this point, you're dead. So that's a problem. The R3 Corda, okay, the distributed ledger, is a little bit different. So it's basically, you share data selectively. Not everybody has the same data. Okay, it's private. definitely private. It's no surprise, it's for banks and insurance companies, of course. Okay. So centralized body, that's one thing that they kind of establish themselves as a notary, and they say, okay, so we have a centralized body. Of course, it's a collection of planned private networks, so it doesn't have this nice kind of flat public network that blockchain has, the typical blockchain has. Okay, and of course, the parties must trust the notary, they must trust the central organization. It goes without saying. Okay, notary node for transaction verification. Okay, and of course, cryptocurrency not available. But the good news is there is no 51% attack, which is possible. Now, the flip side of that is if you find a way to attack the notary, you kill the blockchain. But of course, they're going to swear to us that they cannot be attacked. So what do we do with distributed ledgers? And actually, it's a little bit different from what we typically do with blockchain. So you can basically share data assets across multiple organizations, which is very nice, because you trust the network. Okay? You can tokenize assets, which is very important in financial services. Supply chain management, that's a typical blockchain use case. Okay? And my favorite one is digital identity. Now, you notice something on this slide. I didn't put a time frame on purpose. I'm not that crazy. Nobody seriously can put time frames today, especially for digital identity. We think that that's going to be one of the killer use cases. We don't know when. Every time I talk to analysts, for example, Gartner Group, they tell me it's coming, it's going to be in 10 years. The problem is they tell me that every year. You know the old joke of the dog with the stick and the stake, that's the whole thing. So we don't know when that's going to happen. Now, what we do know is there are a couple of things we can do today. So just, I'm not going to turn you into reinsurance experts, because that's the hard field. So basically, a reinsurance treaty is actually a great use case for blockchain, because reinsurance just means that we insurance companies sell insurance to other, so we basically get insured by other companies when their exposure is too high. And that happens all the time. What we also use that for is, for example, if we deal with a company that has offices in countries where we don't operate, we basically sell a portion of the policy to insurance companies that operate in that country. Easy enough, right? So the problem with that is we administer the policy. We get the payments, we get the claims, and so on and so forth. Claim reimbursements. You can't do that if you don't have a complete picture of what's going on with the customer on a global basis. Okay? And the way we do that today is, of course, we ping every company inside the network, or the reinsurance network. And we ask them, we say, okay, so what? And we do that on a monthly basis. And you can imagine the reconciliation is just endless. We actually have issues reconciling within travelers, if you can imagine. So you can imagine how bad it gets when you start getting outside travelers. So the idea would be basically this. You start having each of the seeding companies. Seeding companies are the ones who buy the insurance from us. Each of the seeding companies start basically being on the network and having their policy and claim data. The host node administers the whole thing, and we're here, and we can actually pull the host data when we did that. Again, this is all trusted for that. Okay? Sounds great, right? Now, a couple of issues with that. Okay? Number one, another thing that is very, very critical to remember, true blockchain use cases are hard to find. You're going to find a lot of companies that say, oh, yes, let's do a POC on that. But the key thing, remember Occam's razor? Okay? The key thing is really, is blockchain the simplest solution to solve the problem you're facing? And most of the time, the answer is no. Okay? A distributed database will do the job much better than blockchain. That's the first thing to keep in mind. Okay? In insurance where my sandbox, right? Potentially excellent use cases. Another one is certificate of insurance, which is another big use case. We should work on that one. And certificate of insurance, in case you don't know, when you hire a contractor, at least in the US, okay, contractor is supposed to demonstrate to you that they have insurance. I know most of us don't ask because we don't want to hear the answer, but they are supposed to. And of course, the contractor could have insurance with multiple insurance companies. I know and a clear blockchain use case. Okay. Most people focus a lot on the technology. Okay, so the right technology, distributed ledger versus through blockchain, and of course the small vendors are not going to survive in the long run. But that's almost not important. What's critical is the next point. The business networks. You cannot do blockchain alone. That doesn't work. Okay, so you have to have some kind of association, consortium, something that basically, and remember, the people who are going to play with you are your competitors, not the kind of people who usually like to talk to you. So keep that in mind too. Okay, so joining a consortium helps a lot. That's important. Okay, in insurance, for example, we believe at this point, or at least I believe, that what's going to make adoption of blockchain basically happen is if an event, and it's probably going to be a bad event, forces insurance companies, shoot, we've got to do something now. That's what's going to happen. Until that happens, it's going to be very much put a toe in the water and so on and so forth. And of course, joining a consortium helped. We joined a consortium about a year ago, Jean-Louis Block, and that kind of had a lot of focus on our efforts. The problem with consortiums is that they are most of them immature. You meet a lot of lawyers, not the kind of people you exactly, and they're going to tell you what you cannot do. That's what you want to hear. So, work in progress. And of course, an architectural approach is essential. This, by the way, I really believe that, and I don't know when, this is going to change the way we architect our systems, totally. Oops, too fast. So in conclusion, basically, yes. So innovation is critical. Architecture is critical in supporting innovation. Something it's hard to explain, but something that we need to be there. We need to be part of the innovation efforts. Okay. Yes, it's an extreme case of Agile. So what? I mean, we are part of Agile. I mean, we kind of the old days where the Agilistas didn't want to talk to us are long gone. I hope. Okay. So critical is scaling MVPs. Reusing innovation, and of course, I hope that by now I convince you at least that it's critical in AI, ML, chatbots, and blockchains. Thank you.